Okay, in this section, we focus on medical image segmentation. We will introduce the basic concepts of medical image segmentation and introduce some famous, widely used traditional medical image segmentation algorithms. The first concept is dimensionality. There are two kinds of segmentation algorithms, 2D and 3D image segmentation methods. If a method is conducted on 2D images, so we call it a 2D image segmentation algorithm. If an algorithm is performed on 3D images, we call it 3D image segmentation algorithm. Compared with 2D images, okay, in which most images are 2D images. In medical domain, there are a lot of 3D images in clinical practice, such as 3D CT, 3D MRI, and 3D ultrasound. Okay, so 3D segmentation is one of the most important research direction in medical image processing. Okay, it is also a difference between the natural image processing and medical image processing. Okay, in medical domain, there are a lot of 3D images. The second concept is interaction and performance. Some segmentation algorithms are fully automated. But in many cases, okay, fully automated algorithms cannot achieve satisfactory results. So in such a case, interaction from users is necessary to improve the performance, the accuracy of the segmentation results. So in this case, in many algorithms, okay, we ask the doctors to provide initial regions or initial points, and based on the initial regions and the initial points to carry out the segmentation tasks. Okay, so in many cases, such a manual interaction is necessary to improve the accuracy by incorporating prior knowledge. Okay, but for large population studies, okay, such manual interaction can be laborious, time-consuming, expensive, costly, right? We cannot ask a doctor to provide interaction in a large number of images. Okay, it is expensive and time-consuming, particularly in 3D image processing. Okay, we should ask the doctors to provide the interaction slice by slice. Okay, it's laborious and time-consuming, right? The next concept is validation. Okay, how to validate if medical image segmentation algorithms is effective or not? Okay, currently the golden standard is also the manual segmentation results provided by doctors. Okay, usually we compare the results of our automated algorithms with the results, okay, manually labeled by doctors, okay, to evaluate if automated segmentation algorithms is effective or not. Okay. Then we introduce some famous and widely used segmentation algorithms. Okay, the first one and the most widely used is the thresholding algorithm. Okay, in such an algorithm, thresholding algorithm, segment images by creating a partitioning of the image intensity. Okay, for example, we specify a intensity threshold and use this threshold to partition the image into two parts. Okay, but okay, in many cases, okay, it is difficult to choose a suitable threshold, quite difficult. Okay, for example, you can see the figure A. Okay, you can see the intensity distribution of an image. Okay, based on this distribution, okay, it's difficult to choose a suitable threshold, right? To segment the image. So to handle such a case, multiple thresholding and adaptive thresholding methods are proposed. Okay, that means, okay, we only two we use 2 or more thresholds to segment an image, or we use one threshold in one region in the image and use another threshold in another region, okay, in an image, adaptive threshold, okay. But the traditional thresholding methods, okay, have some obvious shortcomings, okay. First, it does not take into account the spatial characteristics of an image, okay. Imagine that, okay, if we have two different tissues, okay, located in different location in an image, but have similar threshold, similar intensity value. Okay, so if just use a threshold, it's quite difficult to distinguish these two tissues or organs. But if we integrate spatial information into the algorithm, we can easily, okay, distinct these two tissues or organs based on spatial information. Okay, so you can see one of the most important shortcoming of thresholding algorithm is it does not take into account the spatial characteristics of an image. Second, traditional thresholding algorithms is sensitive to noise and intensity in homogeneities. Okay, in homogeneities. So as we know, in some image modalities, there are a lot of noises, particularly ultrasound images. So quite difficult to use thresholding methods, okay, amid this noisy environment. So in such a case, okay, incorporate information based on local intensity and connectivity, okay, is a solution, okay, to improve the accuracy of traditional thresholding algorithms. On the other hand, we usually, okay, in many cases, we usually use the results obtained from thresholding algorithms as an initial step in a sequence of image processing operations. That is, we use the thresholding algorithm to achieve initial results, and based on the initial results, to conduct a more complicated algorithms to further refine the results and to achieve more precise segmentation results. The next commonly used method is region growing approaches. Okay, in such a approach, the users extract a region of an image that connected based on some predefined criteria. Okay, such a method usually has two steps. Okay, first, okay, we ask the users to manually select a seed point. Then, based on the seed point, we extract all pixels connected, or voxels in 3D images connected to the seed point by predefined criteria. Okay, predefined criteria. So there is a obvious disadvantage of a region growing algorithm. Okay, it is that it requires manual interaction to obtain the seed point. Right? We should ask the users to manually, okay, select a seed point. Okay, this is a main disadvantage of this algorithm. Another disadvantage is that it is sensitive to noise and intensity in homogeneity. Okay, this is cause the segmentation results, okay, may be disconnected. Okay, as this error show. Okay, in this figure. Okay, there are some disconnected regions. Okay, in this figure, you can see from this example. Okay, the next commonly used method is classifiers. Okay, classifier methods are pattern recognition techniques that seek to partition a feature space derived from the image using data with known labels. A feature space, what is a feature space? A feature space is a range space of any function of the image, The most common feature space is the image intensity themselves. Okay, intensity, okay, is the simplest feature of an image. Okay, very simple feature of an image. Okay, remember that I introduced the concept of intensity histogram. Okay, in the first session of this lecture, right? So a histogram is an example of 1D feature space. Actually, the intensity histogram is an example of 1D feature space. Okay. In principle, classifiers are known as supervised methods. Supervised methods. Things require training data that are manually segmented, and then use this training data, manually segmented training data as references for automatically segmenting new data. So in this principle, okay, based on this principle, okay, classifiers are known as supervised methods. Okay, the supervised learning is a very important concept in machine learning. Usually, a supervised learning method has two stages: training and testing. Training and testing. Okay, imagine that. Okay, we want to classify an image into different categories. Okay, such as liver, stomach, heart, or prostate. Okay, we want to classify an input image into different tissues and organs. So to do this, the first thing is we collected a large number of labeled images by doctors, okay, including these tissues and organs, right? Then we input, okay, this labeled data, okay, into the methods, and extract features from these methods. And based on these methods, we calculate a vector of scores, and we hope that the score of the desired category has the highest score. For example, we input the liver and liver image, Okay, we hope the liver category has the highest score. Okay, so that we can have the correct classification results. But this is unlikely to happen before extensive training. So in the training procedures, we usually use the objective function to calculate the errors between the output scores and the desired score patterns, or the ground truth. Then, during the training procedure, we adjust the parameters of the model to reduce this error, Okay, to achieve the correct classification results. The adjustable parameters in these models are usually called weights. Okay, in the training procedures, we continuously minimize the objective function to reduce this error. Okay, to make the classification results more and more accurate. So in the testing and prediction stage, we input an image without labels and give scores, and based on scores to classify this image to different categories. So this is the basic procedure, okay, the basic workflow of a supervised learning methods. First, given an input image, and we produce an output in the form of a vector of scores, okay, and then we compute an objective function to measure the errors between the scores and the ground truth, okay, as I mentioned, and then we modify its internal adjustable parameters, also called weights, to reduce the error. Then we compute the gradient vector, okay, indicates by what amount of the error would increase or decrease if the weight were increased by a tiny amount. Such a procedure is called stochastic gradient descent. Okay, based on the SGD algorithm, we continually training the model, okay, to make the model more and more correct. Actually, deep learning model, okay, many deep learning models are kind of supervised learning models based on supervised learning. So we will introduce more concepts and details on supervised learning in next two sections when we talk about deep learning models, okay, and its application in medical image segmentation. Okay, the next famous segmentation algorithm is clustering. Clustering algorithm essentially performs the same function as classifier methods, but without the use of training data. Okay, no training data. So in such a case, clustering algorithm is in principle an unsupervised learning method. So in order to compensate for the lack of training data, okay, a clustering algorithm usually iterate between segmenting the image and characterizing the properties of each class. That means, okay, a clustering algorithm segments an image and then using some evaluation criteria to evaluate the segmentation results. Based on the evaluation results, further refine the segmentation results. Okay, so iterate between segmenting the image and characterizing the properties of the segmentation results. Here I list some famous clustering algorithms. Okay, K-means algorithms, fuzzy C-means algorithms, and EM algorithms, expectation and maximization algorithm. Okay, most of these algorithms are quite complicated, so I don't want to introduce a lot of details about these clustering algorithms. If you are interested in these algorithms, you can find some papers, okay, to know more details about these clustering algorithms. There are also some shortcomings of clustering algorithms. First, it heavily depends on initialization. Okay, if the initialization is not good, it's quite difficult for a clustering algorithm to achieve a good segmentation results. So initialization is very important. Second, okay, clustering algorithms are also very sensitive to noise and intensity in homogeneities. Okay, there are also some other segmentation algorithms used in medical image segmentation, okay, such as Markov random field models. Okay, this method is often incorporated into clustering segmentation algorithms. And artificial neural networks, okay, actually, deep learning models are in principle artificial neural networks. So I will introduce details of deep learning models in the next sessions. Okay, in principle, deep learning models are artificial neural networks. Deformable models, okay, it is a kind of physically based models. Atlas-guided approaches, okay, usually the atlas is generated by compiling information on the anatomy that requires segmentation and then used as a reference frame for segmenting new images. The main disadvantage of atlas-guided approach is that accurate segmentation of complex structures is quite difficult due to the anatomical variability. Okay, this is one of the main disadvantages of atlas-guided approaches. So I introduce a lot of famous, briefly introduce a lot of famous and widely used medical image segmentation algorithms. So in the next sessions, okay, we will focus on deep learning models. One of the hottest topic in computer science and engineering, and how to use deep learning models for medical image segmentation.